as I introduce this decision tree, I would want you to be looking for, April 2022, question number 5b. April 2022, question number 5b. April 2022, question number 5, bold. Question number 5, bold. Question number 5, bold. But there are two things I would want you always to be remembering in decision trees. The symbols. We have got two symbols. Whenever we want to draw a decision tree, we've got two symbols. We have the box and what we call the circle. Box and circle. So this box is where we shall be having what we call the decision alternatives. Decision alternatives. So anytime we tell you to choose an option, to decide, you shall always be making your decisions right from inside a box. These are decision alternatives, and these normally they are non-probabilistic. Non-probabilistic. And then, of course, in this case here, the circle, this one is an outcome node. Outcome or states of nature node. States of nature node. You can see it's circular, very slippery. Very slippery. Because you're not aware, you are not assured of which outcome you will be able to get. Outcome or states of nature node. They're also known as probabilistic nodes. They're also known as probabilistic nodes. So that is it. So anytime we talk about decision tree, we are looking at a diagrammatic representation of our decision-making process. So our decision-making process, we draw a chart of our decision-making process, and of which I would want us straight away to look at this question. It's normally available, but before I look at this question, there are cash flows that students are not able to discount. Imagine big people doing advanced level paper, and there are cash flows they can't discount, but you can't blame them because being an accountant is never an easy thing. So if, for example, you are given something like this, 0, 10, and then we have in this case here, for example, 1, you get 5. Then we have from year 2 to year 6, you get in this case here 7. Then you have, for example, years, these are 5.5. Then you have from year 7 to year 10, you have 4. This is the times 0 we are investing. And then we have cost of capital. Cost of capital is 10%. And then you are required here. I will need to use this concept while tackling this. You are required to give us net present value. Cost of capital is 10%. Cost of capital is 10%. And then you are required to give us net present value. Now, here, of course, I will need what we call the discounting factors. Sine query. So discounting factor using what rate here? 10%, isn't it? Using 10%. So of course, times 0 is today. Here we don't discount. Times 0 is today. So in short, the discounting factor will always be what here? 1. Times 0. Discounting factor times 0 is always 1. When I come here, I'm getting this lump sum at the end of year 1. So at the end of year 1, then I would want to get the PV, 10%, end of year 1. You have that in your tables. PV, 10%, end of year 1. PV, 10%, end of year 1. How I wish I would get so many guys giving me answers here. 0.9091. Oh, 6209 natoa wapi hiyo sasa? Inakuwa 0.9091, isn't it? Because remember, this is PV, because it's a lump sum amount, one off. PV, 10% end of year 1, giving us 0.909. Can somebody in this case interpret for me this thing here? 2 to 6, 5.5. Yeah, team, if you wish, you can use the formula, but I want you always to be reading. Whenever you have like 10% is available on the tables, I will not waste even a single second calculating. But of course, as team is telling us there, you can as well decide to use this PV equals what here somebody 1 plus R raised to negative n, isn't it? And R is the cost of capital, it's 10%. So it will be 1.1 raised to negative n is the time period. So this is what they did to get this 99. Some of them, not all of them, some of them. That's what they did. But now, how about this 2 to 6, 5.5? How do we interpret this? It will be an annuity, which is 5.5. Receivable from years 2 to year what? Year 6. Receivables from year, yeah, you're right. So meaning that these has to be expanded. And how do we expand this? It's not easy. So many guys will not be able to get this expansion in an exam. So they want me to give them PV for years 2 to year what? Year to year 6A. PV for because of this being now an annuity. Then this needs expansion. How do I expand this? So it will be PV for what year? 6 minus PV for who? 2 or 1? 1. Because ukiangalia ile macho ya ndani, ile mbona naomba Mwenyezi Mungu akusaidie uweze kupata macho ya ndani ya kuona sawa sawa. Ya kuona sawa sawa kama ile advanced MA, unajua hapa examiner anataka you see 2 to 6 is always required. So I should be able to see in the number line which one is being cut out. So 2 is not being cut out. Yeah. The one they are cutting out is 1. If, for example, you tell me something like this, if you tell me PV for look at this, 9 to 18. If we expand it, itakuwa PV for 18 minus PV for 8 years. The online meters are able to see this. Because you can see vividly here that 8 is being chopped. 8. Don't tell me to chop 9. Don't tell me to chop 9 because 9 is in the good bracket here. For the upper limit, very good. For the upper limit, I will take PV for 18 minus PV for who? PV for, of course, the lower limit is where I'm already at. For the lower limit, always, the way I master it, the lower limit, I'll always take this lower limit minus 1. I get PV for 8, like that. So when you see this one here, PV for 2 to 6, please, don't let me down in your exams. Don't let me down in your exams here. PV for 2 to PV for 6. It will be PV for of the upper limit, which is 6, minus PV for, take the lower number here, 2 minus 1. So then abracadabra, are you able to see the PV for 6, 10%? Go to your annuity tables, everybody. Go to your annuity tables, not lump sum tables. Is there somebody who is able to see the PV for 6? Oh yeah, I'm alone. It is 4.3, 5, 3. Annuity table. Is that correct? How about PV for 1, 10%? Remember, 10% is what is cutting across here. 0 point something, right? Oh, I'm alone. Please don't leave me alone today. Don't leave me alone today. 9091? Yes. 9091. 0.9091. Would you end up giving me what figure somebody here? Yeah, so 5.5. Yeah, but in an exam, you can't do that. It will really give you a headache. That would be a very long method. Why would you do that? What if you're given here 2 to 6, again 7 to 10, another one 10 to 50? You can't do that. Okay, so then this one here would be this minus this will give me what figure somebody here? 3.4462. So are you able to do this 7 to 10 now yourselves? Are you able to do 7 to 10 yourselves? This needs some expansion and subtractions there. 7 to 10 needs some expansion and subtractions there. 7 to 10. How I wish all of us are able to get this number. How I wish all of us are able to get this number. How I wish all of us are able to get this number. PV for 7 to 10. Let me see the ninjas that will try. PV for 7 to 10. So this will be PV for who? 10 minus PV for who? 6. Which in this case here will be Are you able to see P for 10 on your tables? On your tables, are you able to see P for 10%? Thank you very much, Sylvia. I know they are very tiny numbers. 6.1. 446 minus P for 6, which will give me what figure somebody here? 4.3. 553. So this P before will be 1.78, 1.78, 93. We together up to here. All right. Then come and give me discounted cash flows. Give me discounted cash flows. Give me discounted cash flows. So now you take in this case here this times this, which gives me minus 10. Now you take here 5 times this, which will give me 4 point something. 5, eh? 4.55. Thank you very much. Then this times this will give me what figure? 18.95. Okay. How about the very last one? The very last one, the very last one, the very last one. 4 times 1.78 and 9 is really 7.16. Then you come and add up everything to give me the total present value. You add everything to give me the total present value. Willie Steve. What are we getting? So according to Willie Steve, no, she's giving me the last figure here. Is there anybody who has been able to give us the total? So this minus plus this plus this plus this. 30 points. 20.666. Did you remember to mention there it's variable? Were you able to remember that this is net present value because you have the initial outlay here? Yeah. As we were getting this, we subtracted the initial outlay. And because the NPV is positive, then we say that the project is what here? Is variable. So the online guys, are we together up to here? The online guys, are we together up to here? All right. And these online ninjas, whenever you are free and you are in Nairobi, and we have our physical classes here, you should be able to pay us a visit. You get to study with us physically. You get to study with us physically, especially from next semester, when we'll be doing what we call business data analytics. You need to be visiting us, business data analytics. Not all the time, but just once in a while. Once in a while, you come over here, we study physically here. Once in a while. April 2022, question number 5b now. So April 2022, question number 5. Question number 5b. So they told us something very nice there. Very nice examiner. Very easy questions. Very good names there. Popo Limited is considering a project requiring an initial outlay of how much here? 150 million. The project's life in 5 years, after which there will be no expected salvage value. The possible incremental after-tax cash flows and the associated probabilities of occurrence are given there. So using decision tree analysis, advice. So this one is quite a simple question because I want to draw it. We must start with making a decision, isn't it? And in finance, we are making a decision between what here invest and don't do what here somebody. Do not invest. Invest and don't invest. If you don't invest, what are we expecting to get? Not unless we are thieves. If we don't invest, we get exactly what we got. If you don't invest, you get 0. But if you invest, then you are thrown straight out of the deep end of outcomes. If you invest, then you have, in this case here, outcomes at the end of year 1. Are you able to see end of year 1? You have 2 net cash inflows. Is there somebody who is, sorry, if I invest today, how much am I going to recur here? Somebody? 150 to go. It's a cash outflow. And the moment I invest like this, then I close my eyes and wait for outcomes. So the outcome must always be captured from a circle, isn't it? And I've got 2 possibilities here. Which possibilities are we talking about? We have 2 possibilities here. So end of year 1, we could either get a cash flow of 40 or what you're seeing? Or 45, isn't it? And are you able to see the probabilities? They are 0.5 and what here, somebody? 0.5. Are you able to see that? All right. So that is the first possibility. End of year one, I could either get 40 or 45. And I'm not so sure really of which one between the two I will get. It's a slippery thing. I don't know. So I'm capturing this from a circle. And anything that is captured from a circle must, in this case here, be having what we call probabilities. Now, year one is not the end of my outcomes. I will still have to close my fingers and then see what will be happening in year two. What will be happening in year two? Are you able to see the year two outcomes? Is anybody who is able to see the year two outcomes? These guys can't see. Actually, it is year two to year what year? Right. Year two to year five. Year two to year five. So year two to year five, I can see I will get 40 here. I will get 50. I will get 60. If it is 45 that I will get in year one, then year two I will get 55. Here I will get 60. And then I will get 60 what year? 65 like that. I will get 65 like that. With what probabilities? They have given me the probabilities there. The 0.20. Then we have 0.60. Then we have 0.what here? 0.20 like that. So we have here 0.1. Then we have 0.7. And then lastly, we have 0.what here? 0.2 like that. 0.2 like that. So that is the first thing that you're supposed to do. That is the end of my decision tree. But now I need to come and get what here? Net present values. So because I would want to get workings on my table, I'll grab this. I'll grab this after you guys clear writing this. I'll grab this. Yeah, and those circles, you draw them using freehand. Don't start looking for coins in an exam. Any coin drawn kind of a circle will be too big for you. It will be too big. It's a normal circle. Yani kama ni unataka kutumia coin, basi wewe tuseme kama mkono wako unasemeka sana. Kama unasemeka sana pia ni case tofauti, then you have to use a coin. But kama ni normal tu ya kawaida hii, then no problem. No problem. No problem. So are we having another class tomorrow, Sunday? I happen to be having some time from 4 to 6 here.
No.
Other time?
From 10 to 3.
10 to 3. Then I can fit in from 4, right? Or you will be too tired.
Yeah.
How comes? It's like myself tomorrow, I have been here from 5 in the morning, then consecutively. Until that is the time when I have a free slot, 4 to 6. Then I'm not at the museum, I'm there, and I'm able to stand that. And then most interesting is that I'm standing throughout. You guys are comfortably seated. See that can convince you. That one has fallen on deaf ears. They don't want to hear that. When tomorrow we're so busy. Yes, so good. And then the other thing where you should be able to like my Saturday, Sunday classes, you know, these are like revision. They're not that intense. They're not that intense. They're not that intense. Okay. Okay. Let's leave it at there. So then, have you been able to draw this thing like this? Finished. So please come and give me the discounting factors. I need 2 discounting factors. I need a PV. I need a PV for year 1. What is the cost of capital in this question? Have they given us the cost of capital? 5%. 12%. So do we have 12% in our tables? Like for instance, our tables, do we have 12%? Do we have 12% or no? Equal. So haionekani vizuri, eh? So we can look for it, isn't it? We can look for it. So then this one here will be, I know the formula PV. I know the formula PV. It will be like this. It will be like this. It is 1 plus R raised to negative n. So it will be 1.12 raised to minus 1. 1.12 raised to minus 1. We will end up giving you what figure? 0.9899. 0.89. Frida siku mko mwanafunzi mzuri sana. Frida asks questions and she normally contributes by giving me figures. What about this year's 2 to year 5? Is it PV for PV5? PV5, yes. This is PV5. So PV5, then PV5, years 2 to year, this has to be expanded. These guys are not following. This has to be expanded, isn't it? This has to be expanded. So it will be PV5, 2 to 5. So this one will be PV for what minus PV for what? PV for 1. Nimesikia mtu akisema mahali 2 mahali. Nimekasikia. PV for 5 minus PV for 1, isn't it? Yeah. So assuming in this case here that we don't have 12% of the tables, please check this. This is a shortcut for doing, instead of doing these alone and these alone, which is quite lengthy, we have a shortcut where basically you come and take 1.12, you raise to -5, minus 1.12, I raise negative what here? And then everything you divide by what here? But if you're using this approach, then you give us the modulus. You ignore the negative you get. Don't be very much surprised. You just take your calculator, say 1.12 raised to -5, minus 1.12 raised to -1, whatever answer you get, to say equals first. Say equals first. And then you divide by 0.12. Yeah, years 2 to year 5, of course, these are annuities. It can't be lump sum. This can't be lumps. 40 year 2, 40 year 3, 40 year 4, 40 year 5. Is there somebody who's getting negative something? Yeah, but you ignore the negative because you want the magnitude, isn't it? Yeah, you want the magnitude. The online guys are not telling you whether they've got a negative answer. The online guys can't even write there, yes. Like Joy is great. She's getting minus 2.7 something, isn't it? Minus 2.7 something. Great. So in this case here, then, this one here, the PV for 2 to 5, ignore the negative. So you're getting at 2.7119. What if you used your table approach because we have 12%? Shall we get the same answer? Yes. If we use the tables, they're confirming that if you use the tables, we'll still be able to get the same answer. You'll get the same answer. Is there somebody who has learned something new from there? Is there somebody who has learned something new here? Yeah. All right. So then now we are very okay. We have gotten our discounting factors, isn't it? Step number 2. You determine NPVs for each of these branches. So you call these branches, this is branch 1, branch 2, branch 3, branch 4, branch 5, branch 6, like that. So these are the branches. So you calculate NPVs for each branch, ignoring probabilities. You ignore probabilities. So in this case here, step number 2, NPV, branch NPVs, and we are saying here, ignore probabilities, like that. You start by ignoring those probabilities. Give us branch NPVs. How many branches do we have? 6 of them, isn't it? 6 of them. And then I remember you use what we call the Subaru approach, where, for example, if it's branch 1, this is the road from, in this case here, Earth here, this is Earth. And then this is the heavens, Matwine. So you ask yourself, how do you get from Earth to heavens to end of branch 1? What is the road? This is the road. You only pick cash flows alone. Like the Subaru people, they're very fast. Using road 1 to the very end. So using road 1 to the very end, I can see the first cash flow is the investing cash flow. The initial outlay, isn't it? Using road 1, what is the next cash flow? Are you able to see 40? On the road, we pick them like fruits. You can't go to heaven without taking fruits. So pick 40, don't pick probability. You pick the cash flows alone. But you see the road 1 cash flow, this 40 is futuristic. It must be discounted. Oh yeah, they're able to remember, I forgot mine. What is the PV here? Oh yeah, it was 0.80 something. 8929. And then people here gave us 2.7. 119, isn't it? 119. So for year 1, this has to be discounted. And like, this is being incurred today. This one is initial outlay, not to be discounted. So plus 40 times 0.89 8929 plus, I can see here, we have another 40. Tell you quick. But now this 40 is coming with what discount factor there? I'm alone, but I will overcome. They will understand. They will understand. They will understand. They will understand. So it's just somebody who can give me the NPV branch 1, 2 decimal places, only 2 decimal places. NPV branch 1, only 2 decimal places, only 2 decimal places, 2 decimal places. NPV branch 1, 2 decimal places, 2 decimal places. Yeah, it is the procedure, team. It is the procedure. Procedure number 1, get PVs and PV5. Procedure number 2, get branch NPVs, ignoring all probability. Step number 3, you give us joint probabilities. It is the procedure. It is the procedure. It is the procedure. So somebody is giving me minus 5.81.
Yes.
Minus 5.81. The first one, minus 5.81. That is the first NPV. The first NPV. If you try to put probabilities here, the work will be too much congested. Be too much congested. So 5. Now, be the Subaru driver. The Subaru driver. Is there somebody who is able to use that Subaru approach to give me the NPV for second branch? NPV for second branch. Subaru driver. NPV second branch. Subaru driver. NPV second branch. Branch 2 ndio hii hapa. From earth to heavens. Umeziona hizo cash flows kweli? So itakuwa namna gani? Somebody minus I'm alone. Minus 150 plus 40 times 8929 plus what here somebody 50 times 0 ama 2 2.7119 2.7119. So in this case here, according to Madam Maureen, it is 21.31. 21.31. 21.31. 21.31. So this is 21.31. 21.3. Masimbatia, thank you so much. She's confirming that branch 2 is 21.31. Let me be silent a little bit to see whether there's anybody who will be able to get branch 3 by themselves, on their own. Mary Ann already has an answer. 48 point something. 48.43. 48.43. 48.43. Please continue and finish all of them. Continue and they get to finish all of them. Those branches. Continue and they get to finish all of them. Continue and they get to finish all of them. So we have here branches. Branch 1, branch 2, 3, 4, 5, 6. So mine is to copy. Teaching is nice because I do very little, and I'm the one who will be paid. Wanafunzi walifanyia 21.31, 48.43, 48.43, 48. I'm being given the fourth one as 39.34. 39.34. 39.34. Great. Somebody else is confirming that at 9.34. .89. 52.89. 52.89. Thank you very much. Joy is confirming the same. Joy is confirming the same. Then we have APO student, Maureen, has been able to give me 52.89 as well. That's very good. This is very good, very good, very good, very good, very good, very good, very good. 62.45, the last one, 66.45. So is there somebody online who is able to confirm this figure? Yeah, somebody has confirmed. Is there anybody, I mean, physical here or online, who would want us to confirm, to do together? Anybody would want us to do together one of those cash flows? Anybody would want any confirmation of the working, or are we comfortable? Are we comfortable, all of us, with those cash flows? Please feel free to ask questions. Are we comfortable, all of us, or do you want us to do some confirmations there? It is like they are comfortable. It is like they are comfortable. Now, step number 3, give us the JPs, give us the joint probabilities. Step number 3, go ahead and give us the joint probabilities. Go ahead and give us the joint probabilities. Joint probabilities. So give us here the joint probabilities. So joint probabilities, what do we do? The Subaru approach. So if it's branch 1, you simply go through branch 1, picking this time around the probabilities alone, you multiply them. Because joint means and in probability. Joint means multiply. Joint means multiply. So like if it's branch 1, I will take something. So for branch 1, if I move branch 1, I'll take 0.5 times who? 0.2, isn't it? Because joint means and. So branch 1, I'm getting this, I'm getting 0.2. April man is giving me 0.1 here. 0.1, isn't it? 0.1. 0.1. 0.1. How about branch 2? So like branch 2 here, it is 0.5 and 0.6. Multiply them. Step 3, we are getting joint probabilities. And how do we get joint probabilities? We join them. We join probabilities on a particular branch by multiplying. We join them. We join by multiplying. We join them by multiplying. We join them by doing what here, somebody? By multiplying. So if it is branch 1, you see branch 1 in your branch 1. What probabilities do we have on the road? It is this 0.5 and 0.2. We multiply. You get an answer. Branch 2, we have 0.5 and 0.6. You join them by multiplying them, which will give me 0.what here, somebody? 0.3. How about branch 3? Are you able to see branch 3 probabilities? 0.5 and 0.2, isn't it? Giving me 0.1, giving me 0.1, giving me 0.1. And then we have branch 4. Branch 4, is there somebody who is able to see 0.05, branch 4? 0.05, isn't it? So we have here 0.05, 0.05, and then we have branch 5. So branch 5, what do we have here? 0.5 and 0.7, that will give me 0.35. And then branch 6, lastly, this will be what here? 0.1. So the second last step. Now you have, ladies and gentlemen, you have NPVs and you have joint probabilities. So the next thing is to give us expected. You multiply them, isn't it? You multiply them. So now I can grab this. Now I can grab this. So come and create a column here of NPV times joint probes, joint probabilities. So you take this times this, you give me a figure. Joint probability times NPV. Because now we are incorporating the risk factor. So according to Frida, this is supposed to be minus 0.581. Yeah. The first one, because she has taken this and this, gotten this answer. And then we have here the second one, it will be 21.31 times 0.3 times 0.3. 21.31 times 0.3 times 0.3, which will end up giving me what figure, ladies and gentlemen? 6.393. 6.393. Thank you very much. Equal plus one is giving me 4 point something. 4.843. Thank you very much. Thank you very much, Frida. Thank you very much. Thank you very much. Thank you very much. So the next one is 1.967. $1.967. $18 point something, isn't it? 18 point. 511. Thank you, team. Lastly, is what I know. It is 6.645, isn't it? So you add, remember these are, and don't tell me that when you subtract again to get net revenue. These are NPVs that we have. So the total will be ENPV. The total will be ENPV. Expected net present value. Expected net present value. Expected net present value. Expected net present value. Which will end up giving me what figure? Which will end up giving me what figure when you add up everything? You're going to end up getting something. You're going to end up getting something. You're going to end up getting something. You will end up getting something. Expected NPV. Expected NPV. Expected net present value. 37. 7,780. So these are what you're supposed to compare with doing nothing, and doing nothing was 0, isn't it? So basically, when this is positive, you simply say that investment is what here is viable. Is viable. Is viable. Now, they never asked us about this, but I would want to hear from you guys. What do you think if you were to be asked here? What is the probability of getting a negative NPV in this question? Because they always ask us, probability of getting negative NPV. It will be, you're only seeing it once. Negative NPV is 1, isn't it? Out of how many possibilities? 6 possibilities. Be 1 over 6. Probability of getting a negative NPV is 1 over 6. If they ask about probability of getting a positive NPV, how many positives do we have? 5 of them. So this is what you're required to do in Roman 1 of this question. In Roman 1 of this question, that is what they wanted us to do. To get, ladies and gentlemen, in Roman 1 of this question, they wanted us to get to make that decision, isn't it? Yeah, using decision tree analysis, compute the expected net present value of the project. And then Roman 2, to compute the standard deviation of the expected net present value. I mean, standard deviation. Is there someone who can't compute standard deviation? Do we have anybody who cannot be able to compute standard deviation? I think all of us should be able to compute standard deviation because that was a wide topic in high school, right? Unless you came from high school many, many years ago. But basically, standard deviation is that too. Because generally, how do we get standard deviation? It is x minus x, isn't it? We take the deviation over the x values from the mean, So it is x minus x bar. In this case here, this has to be in terms of what your sum of square. Sum of squares times probability. And then you do what here, you get the square. So anytime they talk about standard deviation, then you normally write like you write a 0 and then you pull a tail. A small tail. You get some other ninjas who are funny. We write standard deviation like these are mitochondria. This can't be a standard deviation symbol. Standard deviation symbol itaki hasira. Unakuja hapo unavuta tu unaandika sigma hivi. Hapo unavuta small tail. Yeah. So when it is in terms of returns, if you remember, when it is in terms of returns, how do we write this in terms of returns? So in terms of returns, I would have said it is returns of x minus expected returns of, because you see mean is the same as expected. All right. Then this has to be in terms of a sum of what you square times what you probability. It can't be really standard deviation if it doesn't have what here. So then how about then standard deviation in the form of NPV? In the form of no problem. So with the standard deviation in the form of NPV, the standard deviation in the form of NPV, unaanza na hii NPV minus expected N. That's the normal deviation. This is the normal deviation, which now must be in terms of what your sum of squares times probability. And then at the end of the day, what do? We put a square. Because they want us, if you look at Roman 2, they want us to compute the standard deviation of the expected net present value. Expected net present value. Let me write this because I can see I'm cutting. So if it is standard deviation, standard deviation in the form of NPV. It will be the NPV itself minus the expectation. So in terms of sum of what you square times probability, and then you do what here, you get a square length. And then I'll come and create a column here where you take NPV minus expected net present value, you square this, and it's probability. And probability. And so NPV minus expected NPV squared times probability. So this is very easy. Are you able to see my net present value, the actual ones? Are you able to see my actual net present values? They're here, isn't it? Like now the first one will be minus 5.81 minus what figure? Can you give me the figure to subtract? Minus 0.581, isn't it? Yes. That's a lie. Remember, ENPV is what you got down here, and it shall be constant. That is why in high school we used to call them X with a bar. The mean. Thank you for bringing up that. So it will be minus 37.779. This is what I will square times the probability. Probability is this one here, 0.1. So are you able to do this abracadabra? Give me answers in 2 decimal places. 2 decimal places. 2 decimal places. So I don't know how you guys can, I know I'm always used to stretching. If you stretch very well, I'll be able to do some 3 lengthy questions up to 9 p.m. Will that be too much? Are you living very far from town? Or you live very far from town? No, you can manage any place, right? Okay. How about the online guys? Are you able to stretch all the way up to 9 p.m.? Or do you have another class? Ah, great. Great, okay. 2 point. Then we can. Yeah, there is AFM, but today I'm not the one coming in. Then there's a problem. There's a problem that we can't continue. We can't continue because David Daco area. So then the first one, students are giving me a figure of 100 watt here. The first one. The first one is supposed to be what here? 190. The first one is supposed to be 190. The first one is supposed to be 190. How about the second one? So the second one, I will take 21. I'm following this approach. 21.31. 21.31. I subtract the ENPV of 37, 0.779. Whatever I get, I square. Corresponding probability now is 0.3. Corresponding probability is 0.3. Corresponding probability is 0.3. So then at the end of the day, what are we supposed to get? What are we supposed to get here? 81.37. 81.37. The online ninjas are able to get this same value. Before I tell Marianne what she will do, get a link. Grace is confirming they're getting it to 1 point. So please now move slowly and give me, move slowly, and then you give me all the values. So remember, for this topic, we shall do all the questions in your past papers. There are topics we must do all the questions in the past papers and the many questions in ACCA. This is that topic that we have to be very serious about. And then the other topic that we must be very serious about is advanced financing decisions. The cost of capital. Very serious topic that we must also do all the questions in the past paper for us to be safe. The moment I cover those 2 topics very well, and then I come and now cover like this one of international finance very well. The others, mergers, acquisitions, and then good theories like that. I'll be able to give you a nice Waheri to the next level, Nobody is failing this semester. We agreed. Nobody is failing. This semester is a semester of VUCA tariff. So somebody is getting, Grace is getting 11.35 now here. 11.35, yeah. And someone else in this case here confirmed that 11.35. Francisca is getting 11.34, which is pretty close to 11.35, which is very good. Which I online students wengi wanapatia answers over here. 11.34, eh? Yeah. 11.34 is popular. 0.34 is popular. Thank you so much. How about the fourth one? Is there somebody who is able to get the fourth one? $0.12. Yes. Wow. Oh, okay, great. 0.12. Thank you very much. Thank you, Michael. Thank you, Joy. Thank you, Grace. Then we move the next one. We move the next one. The next one, what do we have there? The next one. 79.92. Thank you very much. 79.92. 79.92. And then lastly, what do we have lastly there? 82.20, right? 82.20, right? Are we multiplying with joint probability? Let me do the first one. Let me do the let me do one of them. Yeah, because the formula, look at it. What does the formula in this case here talk about? What does the formula talk about? Look at the formula. So for example, this one, sorry for that. This one, it will be NPV. What is the NPV there? It is 66.45 minus ENPV, this one here, which is 37.779, isn't it? And then we square whatever answer you get, Sherry, what you do, you multiply with the probability, joint probability, which is 0.1 here, which is 0.1. Confirm, Sherry, you are able to get that. And then remember, as per this formula, you will come and do what here, you come and add for us. You will come and add for us. Don't take the square root yet, because this square root comes after summation, isn't it? The square root comes after summation. The square root comes after summation. The square root comes after summation. So come and sum all of them. Sum all of them. So you sum all of them. What are we able to get here? What are we able to get here? What are we able to get here? As the expected net present value. So this is 444.95. Oh, 95 or 65? 95. So this is what we will call the variance, isn't it? So therefore, the standard deviation here of the NPV will be equal to the square root of the variance. The square root of the variance, which will be equal to who here? 21 and 1 something, isn't it? Thank you so much. Thank you so much. Thank you so much. So in an exam situation, would you guys have managed to get all the marks here? I'm now moving forward to be okay. But you have to practice, right? You must practice. 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 Is that okay? You must practice. Yeah, you'll win. Thank you so much. So, all right, ladies and gentlemen, then you come here. Of course, in most cases, after you've done all these, they'll come and ask you something very easy called the coefficient of variation. They'll come and ask you to get the coefficient of variation. Coefficient of variation. The coefficient of variation that we call CV. Remember, how do you remember this very fast? CV will be sex in percentage, sex boy that. Sex in percentage. That's how you remember this very easily. It's called the coefficient of what here? Coefficient of variation. Coefficient of variation. So basically, when we talk over this, it will be standard deviation over the mean, over the mean. So standard deviation over the mean. Standard deviation over the mean. So what is the standard deviation that we got here, ladies and gentlemen? We can't remember. 21, isn't it? And then the mean, of course, will be the expected net present value. Are you able to remember the expected net present value? 37.779. Whatever we get, we say times 100. Whatever we get, we say times 100. Whatever we get, we say times 100. Will you ever forget this formula of CB? We shall never forget it, isn't it? We shall never forget it. Remember, CB is a measure of risk. The higher it is, the higher the risk. The higher it is, the higher the risk. The higher it is, the higher the risk. Yeah, so remember the formula CB is standard deviation over X bar. Standard deviation over X bar. And the standard deviation already we have it, right? The standard deviation is 21. 21 over what here X bar, which is the expected net present that we're using somewhere there. We're using this 37.77, 37.779 times 100, which gives us 55.84. And I've just said the higher it is, the higher the risk. The higher it is, the higher the risk. So I hope, Eric, that is okay. Thank you so much. So now that we have to part ways, after a very few minutes, I have to look for a very short question that you can finish. That you can finish in just 20 minutes. In 20 minutes. November 2020, question number 1C.